For centuries, people have asked what makes us different from animals. There have been a bunch of different hypotheses for which human trait is the key: tool use, self-awareness, culture, or our awareness of death, to name a few. But one of the most accepted hypotheses is that it's our language that makes us unique. Lots of species communicate, but as I'll explain, that's different. And for a long time, scientists have wondered where our special, complex language skills come from. Recent research on one of our relatives may shed some light on that question, because there's evidence that orangutans may use language as well, and it's teaching us something about our own. Now, one thing that you will have picked up on is that orangutans aren't our closest relatives. And it's true that we're more closely related to chimps, bonobos, and gorillas than to orangutans. But regardless of how far away they are on our family tree, they're chatty enough that researchers took notice. First, a little backstory on our giant orange cousins. Orangutans are the largest tree-dwelling mammals in the world, and the only living great apes native to Asia. The two most common species are the Bornean and Sumatran orangutans, which are found, unsurprisingly, on the islands of Borneo and Sumatra. It's sort of ironic to be talking about orangutans in the context of language, because they aren't particularly social animals. Adult males pretty much want to be left alone, except for interactions with the females they mate with. Meanwhile, adult females live with their kids until they're able to care for themselves, which can take nearly a decade. But once their baby is weaned, off they go into the jungle, and mom will live mostly by herself until the next baby comes along. But while orangutans aren't known for throwing parties, they are known for their sweet karaoke skills. Adult males have a throat pouch that allows them to make the long call, roars that last for a minute or more and can be heard up to 2 kilometers away, and attract females to mate with. Of course, mating calls aren't unique to orangutans or even to primates. Neither are other kinds of vocalizations, like specific sounds that mean very specific things. For example, mongooses have unique alarm calls to warn about different types of predators. When other mongooses hear the calls, they respond in ways that are specific to that particular sound. So a call warning of a bird might cause them to go to the ground and take cover, while a call about a terrestrial predator might result in mongooses going into sentry mode and scanning the environment for the threat. And baboons recognize threat grunts versus reconciliatory grunts, and respond differently depending on whether they're coming from family or strangers. But there's a difference between communication and true language. True language, the kind that makes humans unique, requires something called recursion. Recursion is the ability to embed phrases or clauses or sentences within each other to create new meanings. It allows us to express a virtually infinite number of ideas. Here's an example. Let's look at the sentence, "I wore the dress that my mother sewed with fabric that my father wove." I wore a dress is a sentence. My mother sewed is a sentence. My father wove is a sentence. All of those have meanings. But when you put them together, I wore a dress that my mother sewed means something different than I wore a dress. My mother sewed with fabric that my father wove is another complete and different idea. And stacking all of that together gets you a completely new meaning than any of the sentences individually or in any other combination. That ability to stack sentences is recursion, which we need in order to express complex ideas. And we can see the difference when we compare this to those mongoose calls. If they've got one sound that means bird and one call that means urgent, they could express bird, urgent, and bird urgent. But that's pretty much the end of it. So while there are lots of animals that can help us learn about the evolution of communication and vocalization, it's a lot trickier to find relatives that can help us figure out where that recursion part came from, at least until recently. But before we get to that, all research needs funding, even ours. So here's a quick ad break.
This SciShow video is supported by JUMP, the statistical analysis software trusted by the largest pharmaceutical companies, consumer products companies, and semiconductor companies in the world. That means a lot of young professionals are benefiting from JUMP in the workplace. The world's 10 largest semiconductor companies use JUMP when they engineer equipment. JUMP helps them automate routine tasks to speed up analytics while maintaining or improving quality. Plus, it works within their systems to bring data from different sources together in one place and help to spot missing or abnormal data quicker. And in the end, all of that means that JUMP helps these companies release new tools into production faster and with fewer errors. To reap the benefits of visual statistics for yourself and get a 30-day free trial, visit jmp.com/scishow.
In 2024, a group of researchers from Europe recorded 66 long calls from 10 male orangutans in Borneo. When they analyzed the rhythms of these calls, they were able to pick out 5 different elements. One of them was full pulses, and the other 4 were sub-pulses that broke up the full pulses. The full pulses themselves were regularly paced across the entire length of the long call. But when they looked at how those full pulses broke down, they found that 3 of the sub-pulses occurred at regular intervals within them. So multiple sub-pulses occurred in a rhythmic pattern of the full pulses, which occurred in a rhythmic pattern of the long calls. That sounds like recursion to me. And in 2025, the same research group looked at what female orangutans in Sumatra have to say when they see tigers, which are their natural predators. Or at least when they think they see them. Because this time, the researchers weren't just recording calls, they were eliciting them by having researchers walk around on all fours draped in sheets that were either tiger-patterned, white, or had patterns of other non-native predators on them. You know, normal research stuff. Hey honey, what did you do at work today? Well, I dressed up like a tiger to scare orangutans into screaming. What'd you do? I did some spreadsheets. They recorded everything the orangutans had to say about this and broke them down into 3 different levels. Combinations, which were sets of sounds less than 0.2 seconds apart, bouts, which were sets of combinations less than 2 seconds apart, and series, which were multiple bouts between 2 and 20 seconds apart. When they looked at the rhythms of the alarm calls from the orangutans, they found that combinations, bouts, and series happened at regular intervals. So a rhythmic pattern of combinations happened in a rhythmic pattern of bouts, which happened in a rhythmic pattern of series. But there's even more nuance in the patterns that suggest the orangutans are saying a lot with just a few sounds. The tempo of a series of bouts was a lot slower when the threat was something that didn't look like a scary tiger and looked more like a researcher wearing a polka dot blanket. And while the series tempo would change, the other parts of the call were all the same tempo, whether the orangutans bought the researchers' costumes or not. That suggests that the general alarm call announces something is there. The tempo of the bouts seems to indicate urgency or importance, and the rhythm of those super short combinations seems to contain information about the specific threat. Now, this doesn't mean that orangutans are speaking in complex sentences, and they probably can't use recursive grammar to express an infinite range of ideas. But it does provide evidence that complex recursive grammar could have evolved slowly from more basic forms of recursion that appeared before we split off from other apes. So what started off as rhythms embedded in sounds may have evolved into sounds embedded in words, which turned into words embedded in phrases, and then finally phrases into complex sentences. And it's our fancy complex sentences that allow us to bring you videos about the evolution of fancy complex sentences. How's that for recursion?